Welcome everyone. In this video we are going to use L'Hopital's rule, which I derived in one of my previous videos. You can access it from the card right now. We are going to use that rule to find an interesting limit. So we are going to have the limit as x approaches 0 of sine of x divided by x. Now this is going to be very straightforward to find. It is going to take a little time. And I want to give this example to emphasize how powerful, how incredibly powerful L'Hopital's rule is. So let's just do this very quickly, and I'm going to say a couple of things about it. So we're going to have, well, let's remember L'Hopital's rule. It says if we have the limit as x approaching something, a value, this can be 0, infinity, positive, plus or minus infinity, anything. If we have limit as x approaches a of f of x divided by g of x, and if this is in the form of 0 over 0 or infinity over infinity, if it is one of our indeterminate forms, then this is also equal to the limit as x approaches a of f prime of x divided by g prime of x. And prime notation here means the derivative with respect to x. So, as I said, this is only correct if this is 0 over 0 or infinity over infinity. Let's see if our limit here applies to this case. If we plug in 0 for sine of x, we will get 0. And if we plug in 0 for x, we will of course get 0. So we indeed have 0 over 0. Then we can use L'Hopital's rule. And from L'Hopital's rule, we would say the limit as x approaches 0. Well, what is the derivative of sine of x with respect to x? As I proved in one of my previous videos, which you can access from the card right now, it is equal to cosine of x. So the derivative of sine of x with respect to x is cosine of x. And what is the derivative of x with respect to x? It is just 1. Now if we substitute 0, we have cosine of 0 divided by 1. What is cosine of 0? It is just 1. 1 over 1 is 1. So our limit as x approaches 0 of sine of x divided by x is equal to 1. Well, this is great, but I want to highlight this because, come on, this was very short, right? If you know L'Hopital's rule, this calculation takes you a couple of seconds, perhaps 10 seconds maybe, if you do it very quickly. But this is actually very important. This is even called the small angle approximation, right? We use this in physics. We assume that sine of x is approximately equal to x for small angles less than 10 degrees. It is the convention, I believe. And there are other ways to prove this. I even proved that this is the case using linear approximation, which you can find from the cards. You can also do clever geometric ways using the sandwich theorem and other stuff. They get a little bit more involved than this one. This is just very simple. You take the derivative twice, you plug in 0, and then you have your answer of 1. So I think this is a great case that shows how powerful L'Hopital's rule is. Anyways, this is it for this video. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.